Day 9. Day 9 of 12 days. Welcome, everyone. I'm Olivier Godement. I lead the platform product at OpenAI. Today, I think, is the best day. I'm very biased. Today is all about developers and startups building on top of the OpenAI API. Zooming out, we've had an API for, 4 years? The scale is incredible. 2 million developers building from more than 200 countries. Pretty cool. And so, as a thank you gift, we have several new models and features to announce today to thank you for being a part of the community. So kind of a small dev day, I don't know, North Pole, Santa edition. So Michelle, take it away.
Thanks. I'm Michelle Pokras, and I work on our post-training research team.
Hi, I'm Brian John. I'm also on the post-training team at OpenAI.
Awesome. Well, like Olivier said, we just cannot stop doing dev days. So here's another small one. Today, I'm super excited to tell you that we're launching O1 out of preview in the API. Since we announced OpenAI O1 preview in September, developers have been building super cool stuff on the API. Agentic applications in customer support or financial analysis. And also, it's just a phenomenal coding model. So we've been really excited to see that. But we've also heard feedback from developers that you're missing kind of the core features that you've come to expect on our API. And today, we're launching them in O1 in the API. So we're launching function calling, structured outputs, and developer messages.
Cool.
And developer messages are a little new. They're a new spin on system messages, and they're actually part of our instruction hierarchy work to teach the models which kind of instructions to follow in what order. So the developer message is controlled entirely by the developer and used to steer the model. Finally, we're also launching reasoning effort. This is a new parameter that tells the model how much to spend time thinking. It's really helpful to save a little time and money on easier problems, and then you can spend more compute on the hardest problems where you need it. I said finally, but that's not true. We're also launching vision inputs in the API.
Awesome.
People have just been really asking for this, and we think it'll help a lot in cases like manufacturing or science. So super excited to see what you build there. But actually, let's see a quick demo.
Yeah. All right, let's walk through a live demo to see some of the O1's new capabilities in the API, starting with vision. So for that, I've prepared the photo scans of a text form that I filled out with some fake data the other day, but I had some mistakes in there. And I wonder if O1 can help us detect the errors in the form. But just a quick note before we get started, while O1 can help us detect errors in forms like a text form, it is not a substitute for professional judgment, of course.
Of course.
All right, I will open up our developer playground, which is a really nice UI for experimenting with OpenAI's models in the API. At the top, this is our newly introduced developer message. This is where you can provide the model with some high-level instructions or sometimes detailed instructions on how it should behave as a model. I have a pretty simple one here. And then I uploaded the images from my form and asked the model to spot for errors. While O1 is thinking, let's jump back to my form to take a look at the errors that I had. So the first error I had is on line 11 for calculating adjusted gross income, AGI. I was supposed to subtract line 10 from line 9, but I did the opposite. I used addition.
We've all been there.
Well, it happens.
I got a little too excited every time I see the word AGI. The second error is I used the wrong standard deduction. Looking at the chart on page 4, standard deduction depends on both the filing status and also the number of checked boxes on page 1. So this means for O1 to figure out the correct value for standard deduction, you need to reference content for 2 other images. Let's see what the model get back to us. All right, let's see the model. Great, it noticed the arithmetic error on line 11. I was supposed to use subtraction, that's good. And it also noticed the standard deduction amount is incorrect, which is also right. And based on that, of course, I need to adjust my taxable income and subsequent tax. All right, after fixing those 2 errors in my form, I know my taxable income now arrives at $9,325. Next up, I will ask the model, based on the information from the form, how much income tax do I owe if my taxable income is this? So what do you think the model will do here?
Really hoping it gives us a good answer.
Well, O1 doesn't have access to the latest up-to-date 2024 tax table, but it does have access to a set of functions we provided on the right. Functions are a way for the model to interact with your backend APIs. So here we can take a look at one of those functions. So we provided, it's rendered in a JSON schema, and we provide with a high-level description for what the function does, and the set of arguments the model needs to provide to call the function. So this is our function calling feature.
Makes sense. So the model calls this function. We can call this on the back end, get the correct tax data, send it back.
Exactly. Looks like the model called the correct function here with the input pulled from the image.
Does the user see any of this?
Not really. So this all happens in the backend of your app. The user will not see any of the function calls nor the response from your API. So after we get the response, we will send that back to the model, and O1 will respond to the user in a very nice-looking user message. So here it tells the user about their new updated income tax after the correction.
Awesome.
Way better.
But that's not all. I wanted to show you one last thing, that's structured outputs. I will ask the model here, what corrections do I need in my forms? But before I hit enter, I want to provide the model a JSON schema for the response format. This will instruct the model to output according to this JSON schema. And on top of that, we also implemented solutions on the API backend to ensure the model output adhere to this JSON schema 100% of the time.
Makes sense. Actually, let's take a quick look at this schema. So it's called form corrections, and it's got a list of corrections. And each correction has what you'd expect. So there's the reason, so we can display to the user what they got wrong. And then it's got the location. So this is super cool. We can actually render a UI for the PDF and highlight exactly what's wrong with the new value and the old value. So structured outputs is super useful when you don't want to kind of render Markdown from the model and you want to just extract the JSON automatically. So you can see here the model has output the corrections. You can see they're in the nice JSON format. We've got the new value, the old value, all the locations and reasons. And so yeah, this is super helpful when you're building kind of rich, featureful applications. So we just showed you a quick demo, but demos are really not enough to give you the full story. We actually run internal evaluations, which are like tests to see how our features do before we ship them. And so for O1, because it's really important for developers, we ran some evals for API use case. So I'm going to show you a few of these.
Let's take a look.
First, we have function calling. So we have some internal function calling evals. And you can see that this new O1 model is significantly better than GPT-4 at function calling. And this actually includes both halves of function calling. Calling the right function when you should, and not calling a function when you shouldn't. You can also use function calling in conjunction with structured outputs. And you can see that, again, O1 performs much better than 4.0 here. Speaking of structured outputs, O1 also significantly better on this eval. This means the model does a better job of following the format, so we take it less off distribution when we constrain it. Next is coding. Everyone's always talking about coding. LiveBench is an open source coding eval, and we're excited to see that O1 performs much better than O1 Preview and 4.0 on this eval.
That's awesome.
That's a huge jump.
Yeah, and then finally we have Amy. And on this eval, you can see that O1, again, significantly outperforms O1 Preview. But actually, the interesting bit here is that we have on the right O1 with structured outputs. So when building structured outputs, we really wanted to make sure the model performs just as well when using structured outputs as without. So you can see that the reasoning capabilities are maintained even with this feature. So you can use it in your application and not have to worry about the results.
Awesome.
So those are the evals. But beyond the evals, there's actually a really interesting change in latency. So O1 actually uses 60% fewer thinking tokens than O1 Preview,
Nice.
which means it's much faster and cheaper for your application. Finally, we've heard a ton of demand from you for O1 Pro in the API, and I'm sorry to say we don't have it now, but our elves are hard at work back at the lab, and it should be coming soon.
We're working very hard on it.
Yeah.
Cool. Awesome. Thank you so much, Brian and Michelle. To recap, O1 in the API function calling, structured output, developer messages, image understanding will start rolling out to tier 5 customers starting today. You will receive an email, and it will take us a few weeks to get to everyone. So O1 is not the only model that we shipped recently. We've had a lot of excitement on the real-time API. How do you have like natural human-level latency speech application? So Sean, give us an update.
Hey, I'm Sean, and I'm here with...
I'm Andrew.
And I'm here to talk about the real-time API. So if you've never used the real-time API before, it lets you build real-time voice experiences with OpenAI. So think you can build your own chat GPT, advanced voice mode, you can add AI assistants, you can do all these really cool things with AI. And today we have WebSocket support, so you can do server to server and send voice and get responses back. But today, what we're announcing is WebRTC support. And that's really exciting for 3 reasons. The first is that WebRTC was built for the internet. So if you've done conferencing, if you've done low latency video streaming, that all uses WebRTC. And that handles, the constant changing of the internet. It'll change your bit rate. It will do echo cancellation. And so what's exciting is now real-time API gets all of these benefits. So if I build an application, things are way easier and it just works. So to lead that in, I'll show you a little demo application to show you how easy it is to do. So here's a little HTML, and just to give you a structure of it, we have an audio element, we have a peer connection. And what the peer connection is kind of this one-to-one connection between you and the real-time API. And so what we're doing today is we're creating this peer connection, and we're saying when the real-time API sends you some audio, put it into that audio element. Next, we capture the microphone, and we're adding it to the peer connection. So we're saying we're going to send one audio stream to OpenAI. And then now that we've set up this peer connection, we do an offer answer. And what the offer answer does is it collects up all the information locally. You send it via an HTTP post, and then we respond. And WebRTC then goes and does everything for you. There's no handling of congestion control or capturing the audio or any of those other things you had to deal with before.
That's awesome. So how does that compare to the previous WebSockets integration?
So if you were doing WebSockets before, this code would probably be between like 200 and 250 lines of code. And you would have additional problems on top of that. You'd have to handle back pressure and all these things. Like it's one of those problems that you don't realize how frustrating it is until you finally go to production.
I see.
So let's actually run the code and see what it looks like. So here's the code, my audio element. I'll refresh the page.
Hola, ¿cómo estás? ¿En qué puedo ayudarte hoy?
How many days until Christmas?
Christmas is on December 25th, and today is December 17th. That means there are 8 days left until Christmas.
Nice, always exciting when a demo works. Okay, so yeah, so that's all it took is that.
So you just copy pasted the 12 lines, you execute the script, and that's it?
Yep, and we'll put this code out, and so you can just go and grab that. The only thing that you would have to change is your API token. And so you can go and download this code and run it. I'm really excited to see what people build, as we make it way easier. Okay, so the next thing I want to talk about, I'm gonna have to bring out a little friend. So I wasn't able to get an elf on the shelf this year, so I got a fawn on the lawn, a new official toy. So fawn on the lawn has a microcontroller in it. And to give you a sense of, here it is, before I plug it in, here's how big this microcontroller is. Absolutely tiny, like the size of a penny. So I've got the microcontroller in there, and I'm gonna plug in, and we'll see what happens.
Merry Christmas. What are you talking about?
We're talking about adding WebRTC to the real-time API.
Oh, that sounds a bit too complicated for me. How about we talk about something more fun, like delivering presents? There's nothing quite like soaring through the sky to bring joy to everyone on Christmas Eve.
Oh, okay, well, what am I getting for Christmas?
Oh, I'm not supposed to spoil the surprise, but I think you might be getting something very familiar this year. Could it be some coal?
Oh.
Okay. Cool. So we saw using the real-time API in the reindeer. So, but that's just like a tip of the iceberg with all the use cases that you can build. So with something this size, you could put it on, a wearable device like glasses. You could put it into cameras and microphones around the house. So you can have like context-aware assistance. I am so excited for what people build, because with this SDK, all you have to do is set your token and set some details about your Wi-Fi and it connects. Like, these are microcontrollers that you can get off from like any major retailer. You plug it in USB and that's all. Like, I really think that 30, 45 minutes, people can start doing building this up. There's no soldering, there's no hardware. We just have a speaker plugged into a headphone jack.
That's super cool, super cool. And we have other updates to the real-time API. Number one, we heard your feedback on the cost. We are dropping the cost. So from now on, GPT-4 audio tokens will be 60% cheaper than before. And we are also shipping support for 4 Mini in the API. And 4 Mini audio tokens will be 10x cheaper than the current price. The second thing is that we're shipping support for a Python SDK for the real-time API to make it even easier to integrate. And lastly, we're making some API changes to make it easier for you to use function coding and guardrails. So all of that, we hope, and we cannot wait to see the kind of applications that you're going to build. All right, we talked about models, we talked about API. Would love to talk about fine-tuning, customization. That's one of the big needs from developers. They want to customize the models for their own use cases. What do you have, Andrew?
Yeah, so unfortunately, I don't have a reindeer to share.
That's fine.
But we are excited to announce a new method of fine-tuning available in our API called preference fine-tuning. And we'll be using a method called direct preference optimization, which is designed to help you create models that better align with user preferences, which should hopefully give increased performance where user feedback plays a critical role.
So you guys have been shipping a ton. You're on fire for the past few months. But we've had an API for a year, a fine-tuning API. What's new? What's the difference?
Yeah, so currently in our API, we have supervised fine-tuning and the newly announced reinforcement fine-tuning. Most of our users have been using supervised fine-tuning to tailor our models for their use cases. And in supervised fine-tuning, you provide the exact input and output you want the model to have. So if you're creating a user chatbot, you'd give it the user messages and then the exact response. And preference fine-tuning is a little bit different. So instead of the exact input and output, you're going to be giving it a pair of responses where one is preferred over the other. And then our fine-tuning process will optimize it to learn the differences in those responses. And those differences could be things like response formatting, stylistic guidelines, or even abstract qualities like helpfulness or creativity.
I see. So typical use cases would be what? Customer support, copywriting, creative writing?
Yeah, exactly. So if you see our models maybe are a little bit too verbose, or they're giving irrelevant answers, this fine-tuning can help guide it toward more concise and relevant responses by emphasizing the preferred behavior and then de-emphasizing the unpreferred ones. Another really good use case might be content moderation. So for example, if you have a specific style or tone you want your organization to have, preference fine-tuning can help guide it toward that. But yeah, let me show you actually how easy it is to start fine-tuning in our API. So here I am on the platform UI, and I'm in the fine-tuning tab. So when I hit create fine-tune, now you can see that there's a new drop-down for method, and I'm just going to select direct preference optimization. Next, I'll select the base model. In this case, I'll select GPT-4o. And then finally, all I have to do is upload the training data. And like I mentioned before, the format's a little bit different, so I'll go through a quick example. In this example, we're asking an assistant what the weather is like in New York City and providing it 2 pairs of responses, like I mentioned. And maybe we're making a chatbot, so we want it to be a bit more conversational. So in the preferred response, it's a bit more verbose, and then also responds in Fahrenheit. And in the unpreferred response, it's much more concise and responds in Celsius. So I'm going to take these examples, put them in a JSON-L file, where each example is going to contain the input messages, the preferred output, and then also the non-preferred output. So I'll go ahead and upload the data now. And we also provide some hyperparameters to tune, but I will just select the defaults for now and hit create. And so this is going to kick off the fine-tuning process. Depending on the dataset size, this could take anywhere from several minutes to several hours. But once it's done, we should be able to sample from the model the same way we would any base model in our API.
Man, it's so exciting. So have you had a chance for people to use it yet?
Yeah, so we've given early access to preference fine-tuning to several of our trusted partners, and we've seen good results so far. So as an example, Rogo AI is building an AI assistant for financial analysts, and they're using our models to rewrite and refactor user queries to give more relevant answers. When they used supervised fine-tuning, they couldn't quite get it to perform better than the base model, but with preference fine-tuning, they saw accuracy increase on their internal benchmark from 75% at the base model to over 80% with preference fine-tuning. So we're super excited to see what other developers can do with preference fine-tuning, which is why we're actually going to make this available for GPT-4o today and GPT-4o Mini soon at the same price per trained token as supervised fine-tuning. So if you out there are excited to start preference fine-tuning, I encourage you to check out our documentation later today.
That's awesome. That's awesome. Okay, there is a lot to unwrap, lots of gifts. We started with O1. O1 in the API with the full production feature set, such as function calling that people expect, starting rolling out to tier 5, starting today. Then we talked about the real-time API. New API, simpler WebRTC integration, and price drop. And now we're talking preference fine-tuning to make it easier to customize models for your use cases. And that's not all. The team is non-stop shipping. They shipped a few new things today, and so I wanted to show you a few smaller things which are coming up. Number one is we care a ton about the developer experience and product quality. And so we're going to ship, to announce, starting today, new SDKs. We have official support for Go and Java SDKs. You can find them here. Please give us feedback. Similar to the Python SDK and the Node SDK, they support all the API endpoints that you need on OpenAI. So here's the Go one, and here is the Java one. Number two, we care a ton about simplicity. I'm not going to go through the whole flow, but we have a new login, sign up, and flow to get an API key. So there is no need to, sign 5 terms of services. You get an API key in just a few seconds. Next, we did a bunch of dev days around the globe for the past few months. So actual conferences, we loved it. I think the content was amazing. And so we just released today the talks on YouTube. So go check out the OpenAI YouTube channel, and you can find a bunch of pretty cool content. Lastly, all of that was a lot. And so we're going to do an AMA. Ask me anything starting today with the presenters, the API team at OpenAI for the next hour. So please come and ask us any questions that you would like on the developer forum, the OpenAI developer forum. Last. Sorry, I have a bad joke. We talked about call quite a bit. You know how Santa has a naughty list, of kids who are naughty. Why was structured outputs on the naughty list?
I don't know. Tell me.
Santa heard it was a schema. On that note, see you tomorrow for day 10 of 12 days. Bye.